Okay. Now we want to calculate the shear force calculation. So shear force at B. So force at B plus right side forces. Okay. So shear force at B is RB plus right side force. There is no right side force, to take it as RB. So RB value is 7.1455 kilonewton. Next point, shear force at E, we want to calculate here. Sum of the force at the particular point E plus right side forces. So sum of the force at E is 6 sin 45. 6 sin 45, that is minus 4.242. Why it is minus means it is acting downward direction. So take it as minus, plus right side force RB 7.1455. Okay, the answer is 2.9035 kilonewton. Next point, shear force at D. So at D we want to find out here. So force acting at the particular point plus right side forces. That is right side force, already we found that 2.9035. So force acting at the point D, that is 8 sin 60 is minus 6.928. Why minus here means it is acting downward direction. So the answer is minus 4.0245. Next point, shear force at C. Force at a particular point C plus right side forces. That is force at a particular point C is downward direction. That is 4 sin 30 minus 2 minus 4.0245. The answer is minus 6.0245. Shear force at A. So force acting at the particular point, that is reaction at A plus right side force. Reaction at A is 6.025. Right side force is minus 6.025, so 0 Newton. So there is no shear force acting at the supports, that is at the point called A. Similarly, we want to find out bending moment values also. Now, in this problem, it is clearly understood that at the extreme ends are called A and B. In the particular A and B, the bending moment value is 0. So, we don't need to find out bending moment value for the point A as well as the point B. Bending moment at E, you want to calculate. So, here it is acting upward direction. So, in anti-clockwise manner. So, put a positive sign. Reaction at B into perpendicular distance is 2 meter. So RB into 2, 7.1455 into 2, 14.291 kilonewton dot meter. Next point B, D, bending moment at D. There are two perpendicular forces are there. One is RB acting upward, another one is 6 sin 45 acting downward direction. Okay. So RB into perpendicular distance is 4. RB into perpendicular distance is 4 minus, this is upward direction, clockwise direction minus 6 sin 45 into 2. So the answer is 20.092 kilonewton dot meter. Next, bending moment at C, that is acting right side 3 forces at D downward, E downward, at B upward. So if you are substituting the values respectively, we are getting the answer as 12.049 kilonewton dot meter. After calculating these values, shear force as well as bending moment, we want to draw the diagram. First thing, we want to draw the horizontal line. Now, reaction at B, we take it as positive. In the horizontal line, it is called common reference line XY, that is X0X. Upward side positive, downward side negative, RB. So now RB, you calculated already 7.145. Just draw a line, upward direction, 7.1245, positive side. This is called B. Next, shear force at E, we want to find out here. Shear force at E. At E, the value is 2.90. So, the same height you go up to E. Once it reaches E, suddenly drop. After drop, the height from XY is, the height from the datum line X is 2.09. Then, you follow the same height horizontally up to meeting the point D. Shear force at D, here, minus 4.042. Here sign conversion takes place from positive side to negative side minus 4.02 we want to go. So this particular point, the sign conversion takes place, this particular point is called point of contraflexure. This particular point, bending moment will be maximum. We can check while drawing the bending moment diagram for this particular point. After drawing minus 4.02, go the same height left side up to reaching C. Shear force at C is minus 6.0245. Once it reaches C, suddenly increase the value up to minus 6.0245. After reaching that, it goes on same height to A. Once it reaches A point, comes to 0. Why? Because there is no shear force value at particular point A. So you started with the positive side, ended with the negative side. Okay. So draw the hatching line. This diagram is called as shear force diagram. Next thing we want to draw bending moment diagram. For bending moment diagram, we already calculated that there is no bending moment value at A and B. Only 3 points we are having bending moment. So at B is 0. Next you find bending moment at E. The value is 14.295. It is also positive side. Here it is a flat line, horizontal line. Here you draw a tapered line. 14 in positive side. Then bending moment at D, you found that 20.092. From 14 to 20, you make it as a height. Okay, it moves some height with some inclination. This point is called 20.092. After that, bending moment at C, the value is 12.049. It is again reduces 20, 14. Below the 14, you are getting 12. Like that, you draw the diagram. If it is in graph sheet, means the diagram will be very perfect. Now we are manually drawing on the white plain paper. So accordingly, we want to draw the diagram as per the ratio. Now you draw the line here. Here it is a flat line. Here also draw a inclined line. After that, at A, bending moment value will be 0. Draw a taper line. So then draw the hatching line. This shape is called bending moment diagram shape. Okay. That's all about. Now we taken on some. It is related to simply supported beam. One end is fixed, another one is roller end. 3 inclined loads are acting. All are point load. Now we found the unknown value RA, RB, horizontal reaction at HA. Then we found shear force value, drawn the diagram, bending moment value, we drawn the diagram. That's all. Thank you.